For lesson 7.1, we are going to talk about things involving square roots. So to start, let's review some vocabulary. If we have an exponent, and we can draw an example over here, is if I have 3 to the second power, this means 3 times 3. So the exponent tells us how many times to multiply a number by itself. So in the example I gave, 3 to the second means I'm going to multiply 3 by itself 2 times. 3 times 3. If that exponent had been a 5, it would tell me to multiply 3 by itself 5 times. 3 times 3 times 3 times 3 times 3, and so on. A squared number, so 3 to the second power, we read that as 3 squared. So squared means to the second power. And then square roots would be like a number like square root of 9. Square root is the opposite of a squared number and means what did I multiply by itself to get this number? So in this case, what did I multiply by itself? Something times something to get 9. And those have to be the same thing. And it would be 3. So the question mark would be 3 because 3 times 3 equals 9. So then the square root of 9 must be 3. So it's what number times itself will give you that number. So now let's look at some examples. Number 1, we're going to find the square root of each of these perfect squares, which means there is an exact whole number answer for these. So the square root of 25 means what number times itself gave me 25. And that will be 5. 5 times 5 is 25. And really all square roots have a positive and a negative. We're only going to be looking for the positive square root for what we're going to need it for. But technically there is always 2 answers, positive and negative. Number 2, square root of 49 will be 7 because 7 times 7 equals 49. So square root of 49 is 7. Number 3, square root of 100. 10 times 10 makes 100. So square root of 100 is 10. And number 4, 4 times 4 gives me 16. So square root of 16 is 4. Now we're going to estimate. So this one's a little bit harder. So on the left-hand side here, I'm going to make a list of all my perfect squares. Starting with, I guess I'll do 1. 1 squared is 1. 2 squared means 2 times 2. 3 squared, so 3 times 3. 4 squared, 4 times 4. And I'm just going to continue this pattern. And I'm just taking each number, timesing it by itself. 9 squared, so 9 times 9. And then we'll stop at this one. 10 squared is 100. 10 times 10. Okay, so if you don't have these all memorized, you can just work them out and give yourself a list. So now when I look at estimating the square root of 20, well, just as an example, we'll go down to the very last one. Square root of 100 is 10. So the square root side is this one on the right. So I'm looking for the square root of 20. So this right-hand side is the square root. So where would 20 fall? 20 would fall right in between 16 and 25 somewhere. That means that the square root of 20 would have to fall between 4 and 7. So we would say that we're estimating square root of 20 will be between 4 and 5, because 20 is right between their squares. 3, I'm going to look at my square with 3 fall. 3 is right in between 1 and 4. So the square root of 3 has to be between 1 and 2. 40 would fall here. The square root of 36 is 6. The square root of 49 is 7. And 40 would be in between there. So its square root has to be between 6 and 7. Now last one, 12. 12 would fall here. So because 12 falls in between 9 and 16, its square root would fall between 3 and 4. Alright, now we're going to solve some equations using our square roots. So we use inverse operations to solve equations. Let's see, you can write that up over here. Inverse operations. So that is when we had things like plus and minus were opposite or inverse operations. Multiplying and dividing are inverse operations. And a new one then that we're going to look at today is squared, like x squared. The inverse of that is a square root. So on number 9, I'm trying to get the x all by itself, isolate the variable, but it's being squared. So we're going to use inverse operations. And the opposite of a square then is to take the square root. But it's still an equation, so whatever we do to one side, we have to do to the other to keep it balanced. So then I have to take the square root of the other side as well. And then because they're inverses, just like if I have a minus 1 and a plus 1 cancel each other out, a square and a square root cancel each other out. And that leaves just that x on the inside. And then the square root of 16 is 4. Again, technically it's 4 and negative 4, but we're only going to focus on the positive for what we need. Number 10, I see a square. I want to get rid of the square by taking the square root. And then what I do to one side, I have to do to both sides. Square and square root cancel out to give me just that x all by itself, which is what we want. And the square root of 36 is 6. 6 times 6 is 36. Number 11 is a little bit different. I still want to get this x by itself, but I can't just take the square root yet. I got to get rid of this plus 2 first. We want to try to get rid of our adding subtracting first. The opposite of plus 2 is minus 2. So I'm going to minus 2 again on both sides to keep it balanced. This makes 0, so we say it cancels out. X squared is equal to 9. 11 minus 2 is 9. Now we can look at how we were solving these before. And to get rid of that square, I want to take the square root. Do the same to both sides. Square and square root cancel, so I get the x all by itself, which is what we want. And the square root of 9 is 3.